Hey there! Let's dive into some cool machine learning concepts that help computers learn faster and smarter. Ready? Let's go! First, imagine you have a robot trying to guess if a fruit is an apple or a banana. It uses logistic regression, scoring the fruit between 0 and 1. 0 means banana, 1 means apple, and 0.5 means it's unsure. We can create fake fruit data, train the robot, and reinitialize its random weights to help it learn faster. Now let's talk about cross-entropy. Imagine a wise owl guessing if the fruit is an apple or banana. If the owl is right, it gets a low score, which is good. If it's wrong, it gets a high score, which is bad. Cross-entropy measures how good or bad the owl's guesses are, helping it improve over time. Next up, softmax. Imagine you have a bag of colorful candies, each representing an answer like cat, dog, or bird. Softmax takes all the candies and tells you the probability of each one being picked. For example, 70% cat, 20% dog, and 10% bird. Softmax ensures the probabilities add up to 100%, making predictions clearer. Now let's look at the NIST dataset. This is a collection of handwritten digits from 0 to 9. We'll train a softmax classifier to recognize these numbers, predicting how confident it is for each digit. Next, we'll build a simple neural network. Think of it as a tiny brain that finds patterns and makes decisions. For example, when you recognize a friend, your eyes see their face, your brain processes it, and you decide, hey, that's my friend. The network does the same with numbers. To make it smarter, we add more neurons, tiny workers that process information. More neurons mean better learning, fewer mistakes, and the ability to solve harder problems. Now let's solve XOR with a neural network. XOR is a tricky problem where the answer is yes when the inputs are different and no when they're the same. Basic networks struggle with this, but adding a hidden layer helps them solve it. Next, we'll use dropout. Dropout makes the network temporarily forget some of what it learned, kind of like playing with one eye closed. This prevents overfitting, helping the network generalize better. Finally, let's explore Xavier initialization. When a network starts learning, it needs good starting weights. Xavier initialization picks balanced weights so the network learns faster and makes smarter decisions. And that's it. You've learned how logistic regression, cross-entropy, softmax, neural networks, and techniques like dropout and Xavier initialization make computers smarter. Keep exploring the exciting world of machine learning.